So the doors are closed, so I guess we can start. Welcome everyone. I'm a bit impressed, a lot of people, big stage. I feel like a superstar, but I'm not. But at the end, I do give for free business cards. So today's talk is about QGraphics View in depth. So I assume people here have already used a bit Graphics View, because I use a bit of technical words, and I assume people already somehow played with the framework. The agenda for today, a bit of an introduction, history, I will introduce graphics view architecture, basic, and then goes inside details for the view, in details for the scene, for the items, also the lessons we learned while developing this framework, and the future of it, and I will conclude. About me, I'm French. You probably noticed to my accent. I'm sorry, there is nothing I can do. I'm a Qt developer since 2008. I'm based in Oslo. Since the very first days I joined the company, I was interested by working on graphics view, mainly because of my past. I was involved recently, beginning of the year, in QML development, mainly the graphical part of it, like make it work in graphics view. And now I moved on a bit to change what I was doing, and I'm working on Qt WebKit and the WebKit in general. And recently I was working on the HTML5 video and audio elements. On the side note, I'm a KDE developer, even though today I'm using macOS. Since 2006, I joined the KDE development when I was a student. I work on Kplato. It's a project management application. And then I joined Plasma, the desktop thing, in 2007 when they were trying to find people to help. And nowadays I'm actually working on the mobile version of Plasma, which works on my A900 as my spare time. Working in Qt development framework is actually quite cool because I left the French fast food for the Norwegian gastronomy, which is based on sausages and hot dogs. So it's very nice, and also the weather is really cold up there. So, but it's fun to work there. How many? It's like, do you guys? How many? It's like, do you think how many we are for working on QGraphics View? Let's say 10, 20, something like that. How many you think we are? Give numbers, run them. He knows. We are 2.5. There is Björn Erik, my colleague, there is me, and there is a new guy that joined like beginning of the year the company. And there is also some guys working around, but not on the core graphics view. We used to have Andreas, but he left. So it was the main, like the guy behind the graphics view, the guy that created the framework. So a bit of the history of the framework. So QGraphics View was born in Qt 4.2. At that time, it was born to replace the old Qt 3 QCanvas. So the goal of that project was to make a better and easy to use API, because QCanvas, while I was doing the presentation, I was looking at the API of QCanvas and I was like, wow. And so, yeah, basically, when QGraphics View arrived, it was a replacement of QCanvas, the same, trying to solve the same issues, but on a better API and based on Qt 4, basically. Then in Qt 4.3, we basically added features like convenience for, let's say, the rubber band selection for items, Qt transform support, and some little APIs addition, like convenience, like for mapping coordinates in between the scene and the item and so on. Qt 4.4, huge project called Widget and Canvas. The idea was to create widgets, or at least the base, like the building blocks for bringing widgets inside graphics view. By that I mean creation of QGraphics widgets, and also creation of layouts, and also we wanted also to be able to support QWidgets inside QGraphics View, and that's where QGraphics proxy widget arrived. Qt 4.5, A lot of feedback. QGraphics widget, buggy. Layouts, not very nice. I know because I was using them in Plasma, so I was fixing them while I was using them in Plasma. Basically, it was like incorporating the feedback from the people, the customers, the community, and fixing everything. And we also made some performance improvements, but not that much. Basically, faster indexing lookup. I'll explain what it is. Better caching, and stuff like that. But what we discovered back in time is like making layouts is really hard. So we learned it the hard way. Qt 4.6, it's basically the biggest refactoring of the framework. We took our painted code, we throw it away, and we rewrote it from scratch. We moved the indexing logic out of the scene, put in a separate class so we could optimize it separately. And we also introduced QGraphics objects. Was mainly for QML. So QGraphics object is like a subclass of QGraphics item, but also inherits from QObject. And then you can get the property support and all the convenience that you have with QObject. And Qt 4.7, mainly stability after the biggest refactoring that we did in 4.6, like bug fixing, little API additions there on there for QML, and some little tweaks for the performance, trying to do our best, basically. And since QGraphics View is widely used in Nokia, at least for Migo and Symbian 4, we got a lot of feedback from them as well, so I was working hardly to actually fix what they were asking for. So the architecture. I'll just give a basic overview. You guys can figure out while using the framework, and I won't repeat the documentation anyway. So you start with graphics view, QGraphics view. You can have multiple views. It's like a built-in feature of the framework. It's like the views can see they can see the entire scene, or they can see part of the scene. So they basically see a graphic scene. The graphic scene is responsible for managing the items, adding items, removing items. And the graphic scene is responsible for paintings and everything related to events. Internally, the graphic scene, that you won't find it in the documentation, as a graphic scene index. So why we have an index is basically to find the items. Like we can't have just one list of items. We need an index for finding them. And currently, on the framework, we got two indexes. One is the Bsp tree. I will explain what it is. And one is a linear scene index, which is basically a raw list of items. So the three last boxes are internals. You won't access to it. It's not public API. And of course, the index is responsible for managing the items. So the QGraphics items. It's only one of the index. It's like not two, right? Like either you have a linear index, either you have the Bsp. The view. So it's graphics view, right? So as I said, it visualizes a part or the complete scene. It's a QAbstract scroll area because it supports scrolling, so you can navigate in the scene with the view, with the mouse, for instance. And if it's a QAbstract scroll area, then it's a QWidget, which means that it can be top level, it can be put into a layout, and so on. Everything that you get from QWidget, you have it on the graphics view. So as I said, scrolling support. It has also selection support. You can grab your mouse and select items inside with a rubber band, for instance. And the graphics view is responsible, the graphic view receives all the events from Qt, right? From the windowing system, for the event queue, for everything. Receive the paint events, receive the keyboards event, receive everything. And then basically, except for the rubber band, is forward everything to the graphic scene. There is not that much logic for the painted code, not that much logic for the events inside graphics view. It's basically send everything to the graphic scene. The view support transformation, so you can actually rotate. You can do everything that Qtransform support, basically. So rotation, scaling, and so on. So you apply on the view and not on the scene, right? So I won't go more in detail for graphics view. Let's go for tips and tricks, because that's what matters. How you can use graphics view and all the framework the best you can, right? That's the purpose of my talk. First, so graphics view has optimization flags. One is called don't save painter state. So what that means? Basically, when we render the items, like we got the painter from the paint event of QGraphics view, then it goes to the scene, and then the scene say, okay, I need to render items. It's a bit more complex, but let's put it simple for now. So let's say you have to render 2 items, right? The rendering of the item is actually made by calling paint on the item, right? So you get a QPainter, and then you do stuff with it, and then you return, and then we paint the second item, right? That's how it works, let's say the simplified version. So what happens is, like, when we call paint, we give the same painter that we have at the beginning, which means that in your paint function, you can do whatever, right? Changing the pen, changing the brush, doing crazy stuff, right? Which means that when we call paint on the second item, the painter has to be clean. Otherwise, you will inherit everything that you got from the previous paint event, the brush modified, the pen modified, and everything, right? So what happened today is, like, if you use graphic view by default without setting this optimization flag, is like before calling the paint on an item, we save the painter, call paint on your item. You can do whatever you want there, and then we restore the painter. And then we call the next one, save, paint, and restore. So when you arrive on your paint function on your item, you always have a clean painter. So when you trigger this, when you set this optimization flag to true, what happens is, like, we don't save and restore the painter anymore in between items. It's not like a huge performance improvement, like don't expect 2 times faster, right? Because saving and restoring is, like, has been optimized quite a lot on QPainter, but it's still beneficial. So I actually show it in a demo. Up. So I've wrote a small demo. By the way, there will be no super nice effect and so on. It's basic demos with boxes and rectangles. Like, all the fashion needs was basically on Gunnar's talk this morning, or I mean beginning of afternoon. So on this demo, it's basically a simple main window, right? I have a graphic scene here. I set the scene on my graphics view. It happens to be on the UI file. I don't need to go in detail, right? There is a graphics view. I got a top-level parent item, which is a top-level graphics widget. I add it into the scene, and then I got a double loop, which basically adds graphics proxy widgets with a red widget inside. And then, let's see, actually, it's a bit better to read, exactly. So I got a graphics proxy widget, and then set widgets, which is actually a red widget, and then set pose. I basically put them as like a grid, right? And I got my small utility class, which basically give me the FPS. And then I have an animation on the position on the parent item, so the top level one, and I actually ask him to move, right? That's not very advanced example, right? So, and then if you look the red item, which is a Q widget, sorry, yeah. Up, yeah. So, sorry, I was editing the wrong one. So the yellow item, so it's just a graphics widget. I can show the implementation here, which in the paint event does draw text. So it actually draw B. That's really basic. It set the brush to yellow, so the background will be yellow, and the pen blue, so like the border of the rectangle will be basically blue, and an opacity of 0.5, and then just I draw a rect. Basic code, right? So when you run this example, it looks like this. Probably show it in my screen here. Yeah. I need to move it here, up. Exactly. So as you can see here on the button, my FPS tracker actually debug the average milliseconds I spend per frame. And as you can see here, 66, 67, 55, so around 60, let's put it like this, right? Now, go back to my main window, and then here, on the graphics view, I set the flag, optimization flag, don't save pair set true. Let's see what it looks like when I run the app. macOS really annoying. Can't remember the position of the window. So you see, it's like the frames are slightly faster, right? 50 is not like it's not awesome as I said, but it's still like some milliseconds per frame that we save by not saving and restoring the painter step at each time I paint the item. This is the ideal use case for sure. The problem, as I said on the slide, is we don't save the painter state, right? Now let's say I have a red item like this that I put on top of all of them. This one, right? It's basically the same item as the yellow one, but in red. It's just slightly different. If you look the code here, so it create a pen, set the color red, right? So I got the border of the rectangle being red, and no brush. And set the width to 4, so it's like a huge line, and then a bounding right? So what do you expect? You expect a translucent rectangle. When you see this painting code, you expect a translucent rectangle with like a big blue border, red border, sorry, right? Because, and let's see what's happened when you actually run the code. macOS. Here. You see, funny enough, like the content is actually yellow. Why? Because when we render the previous item, the small yellow ones, like we set the brush to be yellow on the yellow ones. And then since we don't save the painter state and restore the painter state anymore, like when we arrive on the paint function of the red one, then the brush is set to yellow. Which means that you inherit of a dirty state of the painter, right? That means that that's why it's actually yellow in the middle. So I recommend to use that flag, and when you have like broken behaviors like this, then you fix your painting code. And it's easy in that case. Here, on my red item, what I can do is painter, set brush, and then cut, no brush. That's what I want, right? Then you ensure that what you want will be on the screen, regardless of the previous state of the painter, right? Otherwise, what you could have done is painter restore and save at the end, right? Save here, and then restore at the end of your paint function, right? But I recommend to set the brush because it's cleaner, at least for me, I think. So when I run the example, it looks like this, translucent. That's what I wanted since the beginning. And of course, now if I remove my fix like this, right? Up. And then I come back to my main window and then unset the flag. And then run it. That's the same results, right? So use the flag. If you have regressions in your code, fix the painting code. That's the best you can do. Up. Let's go back to the presentation. So I did the demo. Other tips and tricks. Graphics view has a cache mode built in inside. So you get two modes. You can either cache the background or do not cache the background. So why? Because graphics view has a draw background function that is virtual, so you can re-implement it. It gives you a painter and a rectangle, which is the size of the view, right? And so you can actually draw your custom background instead of the default one, which is white. When you activate the cache, what happens is that when we call draw background, instead of giving the painter open like the normal painter that comes from graphics view, we actually open one on a pixmap. Then we call draw background, and then everything you'll do will go to a pixmap that will save. And then the next paint event, instead of calling again your draw background function, will actually just draw the pixmap. It's nice, because if you have a complex background, let's say with gradients and really complex background gradients like dotted lines and stuff like that, then it will actually be faster. The drawback is the memory consumption, because let's say your view is huge, like you get at least a pixmap, let's say 640 by 480, then at least the pixmap will be that size. So if you're running on a very low-end hardware and with not that much memory, well, you have to compromise with either you have more memory usage or you simplify the painting of your background. Is other flag that is on it, it's since 4.6, it's the indirect painting. It's actually not a tips and tricks, it's just to remember what it is. Before 4.6, Graphics View had a virtual method called draw items, where you can actually so subclass and override that method and interfere on the painting of the items. I don't know, setting something different from the painter or doing pre-processing or whatever. The problem with this public API is that it was giving a list of items to draw and the style options for them when you paint. And the list of style options was not very optimal. Allocating all of them and giving them to the public function, to the function, and in most cases was doing nothing because not that much people actually override draw items. So since 4.6, we basically deactivate the call of that function, so we change the behavior. It's bad, I know. But at least it doesn't call the public function anymore, so it doesn't allocate all those graphic style options, the Q style option graphics item, and then goes directly to the scene via private functions. But if you do want the old behavior, you can set that flag, indirect painting. And then it will call the old function like before, same behavior as before. But it's slow. It's slower. So sometimes you better think about what you were actually doing in your draw items code and think about, okay, can we do it different way? Because it's not the optimal path. Just remember one thing on the cache mode. Don't activate the cache if on the draw background of your graphics view you just draw a pixmap, because what's the point caching a pixmap, which is caching into a pixmap, right? So it has to be a very expensive draw background code, so that the cache mode will be beneficial. Other tips and tricks. I recommend the usage of set viewport new QGL widget. So basically setting the viewport of graphics view as a GL widget, so you can actually also do GL code in your painting code of the items. Because then the rendering will go through the GL widgets, and then you get some GL acceleration or boost in some cases. For instance, on the Nokia 900, the best couple I could find, at least for KDE, was using the GL widget as the viewport and graphic system raster. If someone comes with a better combination, then I'll be happy. Also, for instance, let's say you're doing full screen app, which let's say you're doing a mobile application, which is full screen. You want to set from style to 0. All those tips and tricks are no big deal, right? I'm not talking about getting like, I don't know, it's like 10% performance improvement. But for instance, getting away the frame style doesn't query the styles, doesn't draw useless stuff, doesn't allocate borders and stuff like that. So when you do a full screen app like a game on mobile phone, well, you better want to set that. For instance, on QML, we do it. Same, if you do a full screen app, you want to set the attribute WA translucent background to false. This attribute means that the background of the graphics view will be translucent. So you can actually do translucency, right? And It depends the operating system you're running on. Let's say on X11, you need to have like a window compositor, like let's say Compose, Kwin, or on Windows it has to be at least from Windows Vista, and macOS it always works pretty much. So, but why you want to deactivate it sometimes? Because on the N900 again, if you set it to true, even if you let's say draw a background which is completely opaque, the compositor, like the window compositing, will try to compose it like crazy to actually try to do translucency, even though you draw an opaque surface on top of it, right? And then your FPS drops like crazy. So for instance, I discovered in Plasma, like one of our issues at the beginning was that. The fact that we didn't set to false the translucent background, because on the desktop version, we do require it. But on the mobile phone, since it's a full screen app, we didn't care. And it was set to true, and as like the frame rate was very bad. So be careful of your old code that run on the desktop, and then you try to port it on the mobile world, and it's true. Also, I recommend the usage of graphic system raster, because it's anyway faster than the native. I think I have a small demo. So on that demo, so you remember I got like 58, 54 FPS, right? Let's say now I go to the project, and then on run settings. macOS or Kit Creator. Should be okay. So you see, like 20 milliseconds average per frame less just by using raster on this simple demo, right? Which just draw rectangles and have a bit of opacity and draw some text, right? What a fight to just show that. So yeah, use graphic system raster. Go for it. Back on graphics view, graphics view has some viewport update mode. What is the viewport update mode? Is like the way we actually send the updates. I mean, the way we actually update the scene. Full viewport update is recommended for viewports like GL widgets. Why? Because QGL widget, for now at least, doesn't support partial updates, right? So you can say, oh, the top left corner has been updated, and as well as the right or the bottom right, for instance. It's always a full update. And actually, in some cases, it's faster in GL to redraw everything than trying to figure out what to redraw. So full viewport update when you have a GL widget is also what I found out to be the best combination for the N900 and Plasma. By default, it's bonding rect viewport update. And to be honest, I think it's the best compromise you can find. It's the best case for many, many use cases. You can try the others. There are 2 more. It's well explained in the documentation. To be honest, it's a one-line change in your code, right? So try it, and then you see if it's beneficial or not. But at least it's nice to remember that they exist and use full viewport update for GL widgets. It really depends the scene, so try it by yourself. Other tips and tricks. If you know the area the view should see, so let's say you know that your graphics view will see the entire scene, or you know exactly the part you will see, always call set scene rect on the graphics view. Why? Because graphics view has a built-in feature to actually trying to fit the content and to see like the optimal part of the scene, and also adjust the scroll bars and so on. And this is an expensive calculation. When you add an item, you know, we have to figure out what we should see and so on, and update the scroll bars and stuff like that. So when you know the area you will see on the scene, always set scene rect, because then we don't need to do those computations. The framework won't do them for you, right? So when you got a full screen app that see the entire scene, then call set scene rect. It's the best code path you can get. Also, there is a fit in view function. So how it works fit in view? I just remember it's basically scale the view matrix and update the scroll bar accordingly to ensure that the scene rectangle fits inside the graphics view viewport, right? So that you can see basically the entire scene. So how it works, it's basically scaled, right? If it doesn't fit in your scene rect on the view, then it will scale everything down so that you can see the entire scene, right? I've seen code. People were calling fit in view because they didn't know exactly what it was doing. And what happened is like the scaling factor that was applied was close to 1, was 0.9 or something like that. So on the screen with your eyes, you can't see it. Like if you look like with a magnifier and stuff like that, you'll see it. But it looks the same, right? With like 0.91, it looks the same. But what happened is like every time we render, like there is a scaling transformation applied on every items, right? So the cost at convenience is basically that you slow down everything for sometimes nothing. So be careful of this fit in view feature. Sometimes you better do it by yourself, scaling the items you really need to see and so on. The scene, so the graphic scene. It manages the item. It's easy. So by managing, it means like if you delete the scene, then it will delete all the items. The scene is responsible for hiding items inside, removing items inside. The scene is also responsible for delivering the events. By delivering the events, is like let's say you get a keyboard event. The scene is responsible to find which item will get the keyboard event. The graphic scene handles the focus. Same, where I should get the mouse input, where I should get the keyboard input, and we will get the focus when the scene will get the focus back. And the graphic scene handles the painting. So what should be redraw, how we redraw it, and stuff like that. So the core feature of the graphic scene need an index. So why? Basically, the index is needed for item lookup. So when you need to, let's say you have a redraw on, let's say, on the top right corner, and you need to figure out what is on this area, what are those items there. So you need to find them fast, right? You cannot just go through one list and then one by one say, okay, are you there? No. Are you there? No. Are you there? No. Right? It will be slow. So, and also for collision detection, let's say you want to know the items that collide with the one you're actually working on, then you need to know the one around you, right? Same. You can't go through all of them to figure out if they are next to you and they collide actually with you. So we got 2 implementations today. Linear, just plain list of items. So linear time lookup. It's actually partially false, but let's put it like this. BSP, so it's binary space partitioning. It's actually the default. I'll explain the next slide what is BSP. So BSP, it's a tree. And how it works is like in the scene, so when you add items and so on, we modify that BSP tree. We basically divide the scene into small parts to create a tree of areas, right? Like I saw in the small diagrams. Look, so let's say the shape, the black shape is like the scene. We divide it in 2 parts. So we got the tree, let's say A, B, and C, and then we divide it to actually have like to basically decomplexify the scene that we have. So that's, and then on the leaf of our tree, we actually add the items. So whenever you want to find an item, you just look the area you're looking for. So let's say, I don't know, a rectangle, and then you look the X and Y, and then you go through the tree by just checking if X and Y of the area B or C is like minus or like bigger or less. And then you basically divide by 2 at each time the areas you're looking for items, right? So it's a well-known implementation, mainly used in 3D. They don't use that much BSP anymore. They use like something like Octree and stuff like that, for instance, on Ogre, like the 3D open source 3D engine. Lookup is fast. as I was explaining, we just divide the areas and then go deep into the tree, and then we have a smaller list of items than the global list of the all items in the scene, right? But as you can imagine, moving is slow because, let's say the item move because of an animation. Well, we need to first finding in the tree fast, but then we need to move it in the tree so that it will have the right position afterwards. Because let's say it moved from the area C to B, it has to move in the tree, right? So keeping like up to date the BSP tree is something that is slow. So let's say you have an animation where the item is like called set pose, set pose, set pose, set pose, set pose, set pose. Like it kills the frame rate. So we come up with a workaround. So the first time you call set pose, we put into temporary, so we remove the item from the tree of the BSP, right? We put into a temporary list, and then we start a timer. And then at each time you call set pose, the timer is reset. Reset, 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 reset. And then when the timer expires, like timeout, then we re-add the item into the BSP. So that's why when you call set pose many times, then it's actually fluid, because we don't need to, at each time we call set pose, we don't need to update the BSP. So it's only when the items become static that we re-add it into the BSP. The problem with that, of course, is if you call set pose or you animate thousands of items at the same time, because then we got all those like timers going on, and then a big list of temporary items that are moving, and which means that when you need to remove them from this list because the timer expired and stuff like that, then it's linear lookup and stuff like that. So it has drawbacks. So the index, you can change it with the set item index method. And then, of course, you might ask which one I should use. BSP, it's basically, it depends of the scene, but you can try it as well. It's a one-line code change. But BSP is usually more for static contents, right? The one that you don't move. Typically, the demo we have, which is like the ship demo, you know, with like 4 views, thousands of items that don't move. This is the best use case. No index is nice for animated scene that doesn't contain that much items. For instance, in QML, we deactivate the BSP because like there is not that much items, like in the ship demo, for instance. So no index is faster. On Plasma, I also put no index because it was faster. Okay, now let's move on a bit, talking about how the rendering works in graphics scene. It's hard to explain, so I try to do my best to actually show it on slides. So first, what happened is like we get our suspects: graphics view, graphics scene, and the index. I put the index as a generic because it doesn't matter if we use the BSP or the linear in that case. So we get a paint event that arises from the Windows system or for anything, like you calling updates, for instance, or the Windows system saying, oh, you need this region is dirty, you need to repaint. Then graphics view basically does nothing. Yes, it actually draws the background and then call draw items. Not the public function, the private one, since 4.6. On the graphic scene, and say, okay, here is the region you need to repaint, and here is my transformation, my view transformation, and redraw. So then the graphic scene needs to find out for those regions the items that it needs to repaint. For that, it will say, okay, I'll go to the index, and I'd like all the top levels for a given area. So let's say if it's on the top left, top right corner, then give me all the top level items that are in that area, and return me a list of that. Right? Just the parents. And then what happens is like we start from the parent, and then we render the subtree, so all the children recursively. So starting from the parent, then the one child, and then recursively all the children of this child, and then to the next child, and so on. And then we do it for all the top levels that is returning, that's the graphics index return. So it's a recursive algorithm for painting. It's actually almost the same in QWidgets. This algorithm is the one since 4.6. Before it was not like that. Before it was iterative. So the only difference with that diagram is basically that when we ask the index, the items for a given area, it was returning everything, not necessarily top levels. So the main problem with this approach was that when you render from the parent and then you do the subtree, right, as I was explaining, let's say the parent has a transformation, let's say 45-degree rotation. So you need to apply the transformation on the painter, right, to paint 45-degree, right? Which means that all the children, except if they ignore the transformation, they will be rotated by 45-degree as well, right? So the painter, the transformation set it on that you set on the painter stay the same while we render recursively the whole subtree, right? Versus the problem with the iterative approach is like since we got random items from different subtrees and just a list which was non-ordered, we start from one item, say, okay, what is your transformation? Your top level, fine, I just use your transformation. Next one. Next one, it can be a children deep inside a subtree. And then we need to figure out, okay, what is the transformation? And then you need to go to the parent to see if it has a transformation, and then the parent of the parent to see if it has a transformation, and so on, until you reach the top level to actually find the transformation for the complete tree, right? And this was a bottleneck of the previous implementation is actually to find out all those states. I'm talking about the transformation, but it can be also the opacity, right? If you have an opacity of 0.5 on the parents, and then the children will also have the opacity of 0.5, right? But if you can set different opacity on all the children, right? And then you combine this opacity, and then that's the same. You need to figure out up until the parents the real opacity that you will apply on the painter. So what we did first is we tried to cache everything. So cache the opacity, cache the transformation, and so on. But that was a bad idea, because when you cache data, it's fine if nothing changed. Like if you have to redo after and after and after the same content, then that's fine. Because the cache, you calculate the cache the first time. Let's say for the transformation, you calculate the cache for every item, their cache transform. But let's say you call set transform. Then you need to update all the caches, right? So the worst part is like if you update the set transform on the parent, then you need to invalidate all the cache on all the children and then recalculate everything back and forth. So painting was faster, but calling function like set transform or set opacity became slower. So at the end, there was no benefits. So it was a bad idea to cache everything, because keeping the cache up to date was insanely hard. So versus now, the recursive approach, the fact that it's recursive, and then at each time we paint a child, we actually give the painter like it is. We actually save those calculations. So rendering by subtrees make it very efficient. And also, the fact that we were caching stuff like make the code really like it was looking bad, and we were not proud of that. And it was like spaghetti code, like even in that case tentacular code, like ugly, really bad. So we said, nah, let's clean it and rewrite everything. The items, so graphics item basically. Friends. It has friends. So the base class is graphics item. It's abstract. You need to re-implement paint and bonding rate. It has the QObject variant. It's exactly the same, which just like the property declaration, and then of course you can have signal slot on it. And I think if I recall correctly, there's also some stuff for the gesture API, because the gesture API needs to get QObject. So use QGraphics item if you don't care of the QObject facilities, and you don't mind of the memory usage, because you know if you multiple inherits QGraphics object, multiple inherits from QObject and QGraphics item. So the memory usage is QObject plus QGraphics item. So if you have a lot of items in your scene, be careful of the memory usage. That's why the QGraphics item was designed to be not a QObject, just for the memory usage. We also have QGraphics widget, I was explaining. It's a QGraphics object also, and it inherits from QGraphics layout item so that you can put it into a layout. It has a geometry concept because of the layouts, right? So you can have like a width 8 and X and Y. Also, it has like font support, palette support, and like size policy support and stuff like that. So it's basically like a bit like a Q widget. And for instance, like if you have ever looked the Migo Touch API for Migo, and also the Orbit, or also known as UI extension for Symbian, they inherit from QGraphics widgets because they put that into their layouts and so on. So they use QGraphics widget. Some tips and tricks about graphics item. The cache mode. Graphics item has 2 cache modes. It's a bit like the background I was explaining before. So what happened, the cache mode, how it works is like, it's basically like if you have a camera, and then you take a picture of the item like it is on the screen, and then you save that picture for the next render, like the next time you render a frame, for instance, so that you don't call again the paint function on the item. So the item coordinate cache is a screenshot like, or a picture of the item untransformed. So if you have a rotation on it, it doesn't work. It will just take the picture of the item untransformed and then rotate the pixmap, for instance. Device coordinate cache, on the other hand, take a screenshot of the item transformed, right? So to make it clear, I did a small diagram here. On the left, item coordinate cache, take a screenshot like it is. If the item was rotated, then I take the screenshot and rotate the screenshot. Device coordinate cache, as you can see on the diagrams, like the dotted lines are actually the pixmap that I'll get, right? So a bit how it works, the cache mode. So when there is a cache set on the item, we don't use the painter that we had from graphics view and then graphics scene. We actually open a new one on a pixmap. We call your pen function. That will render everything into the pixmap. And then when we get that pixmap, we store it into the qpixmap cache. And then I make a bit of advertisement. Since 4.6, there is a new API for qpixmap cache that I've implemented. Is because qpixmap cache, the way it works is like you say, here is a key, here is a pixmap, it store it for you, and then the next time you want, like, so you can throw away your pixmap that you store locally, and then the next time you need to get this pixmap from the cache, you say, hey, I have the key, I want to get it back. And then the cache gives you the pixmap that it saved. So the problem with the key before Cat 4.6, it was that it was QString. And everybody knows that if you want to make something fast, at least when it's a rendering, like when it's in a painting code, you should avoid string operation. So what I did instead is like I've implemented an extension to the pixmap cache that I recommend to use and to port your old qpixmap cache with string-based key to the new API, so that you give the pixmap to the cache, and then the cache gives you a key back, which is an int, or it's like it's encapsulated into a class, but it's actually an int behind the scene. And then you store that key, and then the next time we render the item, for instance, okay, we have the key, we ask the pixmap cache to get the pixmap back, and then we render everything. We just like draw the pixmap that we get from the cache. So when, for instance, you move an item, the first render go into the cache, go into a pixmap that we put into cache, but then the next time you move the item, if you don't call update on it, then it's just reading from the cache and then bleeding the pixmap on the screen. So super fast. if a redraw is needed, like for instance, like you call update on it, then we need to figure out the exposed area that are dirty, basically, and then we render, like we call again paint on your item with a new pixmap, and then we replace the one in the cache by the new version. So I got a demo for it, so you'll see. The cache modes, beware. It's nice, it's fast. Like let's say you got an item that is really complex, with a drawing code quite complex. Then you save like, I mean, it's fast, right? You just render the first frame, and then after it's fast, it's just like bleeding a pixmap on the screen. But be careful, because same problem as the backgrounds on the graphics view is like, it allocates a pixmap, but that is the size of the item, right? So if the item is huge, then you get a huge pixmap in memory. I'm just saying. Device coordinate cache always uses more memory, because as you can see here, the actual pixmap that we put on the cache mode, so the dotted lines are bigger, right? So when the item is untransformed, you better want to use item coordinate cache, otherwise, like the pixmap at the end will be the same, but like the code to actually goes there is a bit different and more complex. So if the item is untransformed, item coordinate cache. And the drawback of item coordinate cache is like it might look bad when the item is transformed, because we operate on the pixmap, right? And then the pixmap, we all know that if you scale a pixmap, it looks bad. So I'll show exactly what's going on when it's wrong. So here I got another demo, which is the cache mode. So let's start a project. Up, I'll close that one. So it's basically the same demo as I had before. So main window, you know, graphics scene, graphics view, a parent item, same. And then I got like again a grid of items. And in that case, there are proxy with the red widget inside. I'll show the code of the red widget, and then I position them as a grid. And same my FPS tracker, and same I have a property animation that moves them down. The red widget is actually a Q widget here, which has a paint event, and then the paint event just draw a rectangle. Basic. So if I run the thing right now, I need to move the window. It looks like this, right? Moving down. This basic example, right? Up, and if you look, the average is like 42, 39, 36, right? Now, let's say on the item, I said item set coordinate, set cache mode, right? And then Q graphics, item coordinate cache. Right, so I set the cache, let's put it like this so you can see better. I set the cache on the item, right? Which means that the first time we render the item, it's rendered into a pixmap, then we put it into the cache, and if we just move it, which doesn't require to, like, I mean, there is no dirty area while moving it, unless if it's opaque, but it doesn't matter anyway. So moving will be basically fetching what we have from the cache and just drawing a pixmap, right? So let's see the frame rates like on that guy. So it builds, and I move it back. Here. So as you can see here, the frame is like 2016 as half, right? In that case, I can close when it's down, here, up. So half, just by using the cache in that particular case, right? Of course, I use a lot of memory here because like I got 10 by 10 items, right? And I activate the cache for all of them. So the memory usage increased quite a lot. So be careful when you use it on the right items, right? On the one that you know it's a painting code complex and it's worth the memory usage. Now, as I was explaining, let's have another example to see the differences between between the device coordinate cache and actually the item coordinate cache. So I got a small example, simpler here, you know, graphics view, graphics scene again, then a top level item parent, and then I have a children, which is the yellow item. I'll show what it does. And then you'll see I will activate and show you the differences between the two cache modes. So if you look the yellow item, which is not anymore yellow, it actually you draw a pix map, which is a wine, because I like wine, I'm French. And the pen is white, and actually writes stuff on it, which is I'm a cached item, right? So if you run the example right now, how it looks like. Of course. Yeah, just moving around, right? Now, if I come back to my main window, what happened is like if I actually rotate by 45 and scale the item by 3 on X and Y, right? So I run it here. No cache mode still involved, right? Oops, I need to put it here. It looks like that, right? So as you can see, the pix map is not high resolution, so it looks a bit crap, but the font is perfect, right? So now let's say I activate the item coordinate cache on it. So if you remember correctly what I said, we take a screenshot untransformed, and then we apply the transformations on the pix map. So the first time we render the item, put it into the cache, untransformed, and then we apply transformation on it, on the pix map, right? So what do you expect to see? You expect to see like the pix map looking as bad as it was here, but the text is not using, it's not using the Painter API, it's basically scaling the pix map, right? So it should look bad, actually, and it will. Yep, I put it back. So I don't know if you see it, but it's actually really pixelized, right? Because why? We actually just scale a pix map, right? Instead of drawing a text on a scanned painter. That's the difference. So now you said, well, but in that case, I just use the device coordinate cache. Well, but that's exactly for what it is made. So if I replace here, by the way, at each time I move the position, there is no call to paint event, no call to the paint function on your item, right? Because it's cached. It's only if you call update or it needs to be updated, then it actually recall paint. So now, if you look here, I change it to device coordinate cache, and then you see, it's nice. Because why? I render the item into a pix map after it has been transformed. So the font was properly rendered, and then I store that pix map. But of course, here the memory usage is way bigger because I scale it by 3, right? So on the item coordinate cache, since I do a screenshot untransformed, the scaling is not taken into account, and the pix map is really tiny. Versus here, I store this huge pix map in the memory. So because I stored the transformed version. So I introduce you the cache mode, and then you have to basically, like, by yourself find out what is the best solution. Caching, no. Device coordinate cache, no. Or item coordinate cache. It's up to you, up to the memory that you have on your operating system. Now you know how they works. Up. Now there is a tips and tricks that only if you have looked at the code, you know how you can use it. It's a third cache mode. I put it into codes because it's not very cache mode, so that you get proper, like for instance, on the two other cache modes, if you get an update on the, let's say just on the top of the item, on the right top corner, then we actually clip the painter so that you only render that part. So you got partial update of the cache, right? now, if you use the graphics effect in a nasty way, you can actually have subtree caching, because all the cache mode that I was explaining apply per item, right? It's only for an item, not for item plus children, right? So it's only for a given item. Now there are many people like say, oh, it would be nice to have subtree caching, you know, because like you render the complete subtree, and then when you move the complete subtree, then it's actually just splitting a pixmap, right? So now let's just explain you how works the graphics effect. So the graphics effect, it's basically we render the items and the item itself. So you can set an effect on the graphics item, and then we render the item and all the children into a pixmap. So why we do that? Because let's say you want to apply a blur effect. You apply the effect on the complete subtree, right? You not apply the blur effect on the parent and then another blur effect on the child, on the one child and then another child and another child. I mean, it's not right. So you should get the complete subtree and then you apply the blur on everything. So now you say, hey, but it actually rendered the complete thing on a pixmap, the complete subtree on the pixmap. So why I couldn't use that pixmap for myself so that I have like kind of a subtree caching? Well, then you can actually, if you subclass your graphics effects and then you use a custom effect, so because the API works that you get a draw code on the graphics effect class, which give you a painter, and then you can actually ask for the source pixmap of your subtree, and then you can apply your transformation on it. Your effects, sorry. So on the blur, or typically on the blur effect, what we do on the draw is like we get this pixmap from the graphics view, right? And then we apply a blurring effect on the pixmap, so it's fast. Fast. Now let's say on your custom draw effects, you just get the pixmap from the graphics view, so contain all the subtree, but you don't apply any effect. You just draw it. Well, then you just have basically a subtree caching implemented. And it just works. I have a demo to actually show. Now, the only drawback of that, as I was explaining, is let's say one of the children get an update. So either you call update on it, or for some reason it has to be a redraw because of opacity and stuff like that. Then all the pixmap is thrown away. And then we have to re-render the whole subtree on it. We have to re-render the whole subtree so you get the pixmap back and then you can draw it. So every update that happens inside the subtree is costly. So that's the only drawback. So now I have a small demo. Up here. Close that one. Close that one. Graphics effects. Up. Source. Usual suspect. Graphics view. Graphics team. I set the scene rect, as I said. Parent item. Nothing. And then just 20 by 20 yellow items. And I put them as a grid, same as before. And if you look the yellow items, they are the same as before, just the B and an opacity and yellow, basically. So same demo. So then now, I got here this caching effect. So if you look the implementation of it, so it's subclass, graphics effect, has the draw function I was explaining, ask the source pixmap, so can actually close that so you see better. Up. So as the source pixmap, and this pixmap that you get is actually the complete subtree. So let's say the parent has many children, then you get the parent plus all the children into a big pixmap, right? And then here, I just draw the pixmap. But in theory, the way you should use the API is when you get this pixmap here, you should do, I don't know, do an effect, right? Blurring, changing the colors on the pixel, whatever, right? But in that case, we just use it and draw it, right? So the first time we render, the guy on the, we render the item that has the effect, then it will actually say, oh, there is an effect. So we should call first draw on the effects, which then render all the subtree, and then get the pixmap, and then draw it. And the pixmap is cached as well. So source pixmap the first time render the complete subtree, but the next time, if nothing has changed on the subtree, it's reuse a pixmap. That is on the cache. So now you said on which item I should set the effect on my demo. So I got a lot of rectangles, right? Moving around. Actually, in that case, the animation is different. Is actually I animate the scale. So all the items in the grid will actually scale, right? So then it's a bit stupid to actually set a caching effect on all items. It will bring me anything comparing to the normal cache mode, right? But what I want is like on this logical parent that is here, that one. That's because all the yellow items are actually children of the parent, right? I want to set an effect on it, on the parent, so that the first time it will render all the children, and then I get a pixmap, and then whenever I need to redraw, I will actually scale the pixmap instead of scaling and redrawing everything. So here, let's say if I run without the effects, you'll see what it looks like and the performance of it. Up, I move it, so you see it scales, right? And then it will stop at some point. So of course the milliseconds per frame is not the same at each time, because like on the very first paint we got many items, then we scale, and then some of them goes out of the viewport, right? So then we don't see them, so you don't see them anymore. So then we just discard the painting anyway. So that's why the frame rate is getting, I mean, the time we spend per frame is getting lower and lower after the animation is getting before the end, actually. So now if I set the effects on the parents, so on my top level that contains all the children, and then I run the animation. So what do you expect for the frame rate? Same as the beginning here. And then it should be constant, right? Because I just scale a pixmap, so the operation is always the same. Up, and then I come here. It draws. So it's slightly faster, as you can see, 41. And it's constant, that I was explaining, because we render first, and then it's just drawing a pixmap. But in that particular case, it's faster, it's nice. The problem is, as you can see, if I rerun the demo, when we scale, look at the text. Since we scale a pixmap, text will look crap, it looks bad at the end, right? So that's the same drawback of the item coordinate cache, because we operate on a pixmap. So when you should use these caching effects? Actually, on my plasma here, you don't see it that much, but the way the panels move is basically we got like a normal screen, and then one that will come. So when you switch the screen, like we scale down the current one, slide it away, then move the next one, and then scale up, right? And those panels contains many items, contains applets, contain everything, right? And of course, you know, scaling, when I do the scaling animation to like moving the panels around, it was slow. And then in that case, I use the effects. I activate the effects only when I move when I start the animation of changing the current panel. Why? Because then when I do the scaling animation, I only do it on the pixmap and not on all items inside. So that's, for instance, one of the use cases I use the caching, like the graphics effect, like this. By the way, if you want to see how I use it, it's on the KDE repository. So I can point you the link for it. QGraphics proxy widget. Haha. It's really tempting, right? Because you can use any Q widget that you already have and put it into the graphics view. It's not fast. Why it's not fast? Because the way Q widget works is that you get a paint event, right? and then a paint event, you don't get a QPainter. You have to open the painter on the paint event, right? So since graphics view share the painter at each time you paint items, it's different comparing to QWidget. We get a painter from QGraphics view, which is a QWidget, get a paint event from graphics view that create a painter, and we reuse the same painter for all the items we render, even for the background. So now there is no way for us to actually give that painter to QWidget. Like, we can't create a paint event for the widget we embed, right? So the only way we can actually render the widget inside the canvas is to call the render function that give a painter, you give a painter, and it render the widgets in the painter. But renders, it's always a full update. So whenever we paint a QGraphics proxy widget in graphics view, it will always be a full update on the widget. So let's say the widget is like 200 by 200, it will be always a 200 by 200, like you always paint the 200 by 200 widgets, regardless the clipping, regardless if it's a partial update at some point. So use it if you have no other alternatives. Really, if you can't write your QGraphics widget subclasses, or if you can't write Qt component, for instance, for QML, or stuff like that. And please don't embed complex hierarchy. The way we thought people will use QGraphics proxy widgets, it was like convenience for a push button and stuff like that. And I've had bug reports on people embedding QMain window, complete apps inside a QGraphics proxy widget, and expect everything to work. Like, I can debug all my life, it won't work. It's just too complex. So it's basically making two different frameworks working together. And so keep with simple widgets. Simplify them and try to use as simple as you can widgets like push button, line edit. Even combo box start to be sometimes problematic, but stuff like that. Because otherwise you get focus issues, painting artifacts, because the way QGraphics proxy widget work is like we map all the events from graphics scene to QWidget and then send them through the event loop. But many widgets, they don't have code for actually handling the fact that, for instance, the X and Y is like 2000, right? Because they're supposed to run on the desktop, which is maximum resolution, I don't know, 1600 by 1200, right? And the scene can be huge, right? So for instance, I remember I had a bug for the combo box, and the pop-up that was showing, trying to be smart. And so if the combo box is on the edge of the screen, it's actually move it a bit so that it's not cut, right? This, for instance, if you were putting the combo box more in the scene on the X and Y more than your screen resolution, then everything was completely broken. So I actually fixed it, right? But there's a lot of problems like this you will run into. Just because your code and our code is not very graphics view friendly. So don't use it. I have a small demo to show how slow it is and why you shouldn't use it. So if I come back to my cache mode demo, because that's fine. Up. So remember the demo, right? I create a proxy widget, and then that I set a widget which is just drawing a red rectangle, right? It was just like this, basically, if you remember correctly. Up, right? So let's see the frames. Oh, it's unfair. It has a cache mode. Of course, I don't see the problem. Up. I put it back on the screen. So you see it's like, 34, 41, 39, around like 30 something. Now let's say I replace my proxy by this yellow graphics widget, which basically if you look, this is the red widget, so it's a Q widget that was just a red rectangle. And here, it's my yellow widget, inherits from QGraphics widget, and does exactly the same thing, but yellow, right? Drawing a bounding right, drawing a rectangle that's the size of the item, and yellow, right? And you see the difference. So I just replace it. Instead of being the proxy and with the red widget, it's just the yellow item. And then, so you get the exact same results, but yellow, right? And then you wait, up, it's down. And then you see the frame like 16, 18, right? So it's basically more than, is at least 2 times slower to use graphics proxy widgets in just the basic example I was showing. So I think about like you are drawing text in the widget, you are doing stuff like that, right? It will be even slower. So please, please, please don't use graphics proxy widget if you don't have a good reason for it. A very good reason, actually. Some ninja tips and tricks. Use set flags with S. With like and using flags and the OR and the binary OR operator, right? For let's say flag 1 and or flag 2 or flag 3 and for flag or for whatever. Rather than many set flag code like set flag 1 true, set flag 2 true. Why? Because first, whenever you change a flag, it will go to the notification system of graphics item, which will call the item change virtual function, right? So that you can react to the flag changes. So you get many times call to item change. So you don't want to do that actually. Sometimes, like really, what's the point? You better have one call with all the flag changes, and then you can do your stuff anyway. Also, some flags need to update states internally for the graphics item. Let's say you changed where items clip children to shape, which means that if you set it to a parent, then all the children will be clipped to the shape of the parent. What we do is on the children, we say, okay, if you're out of the geometry of the item, then we set an internal flag to say, well, then you don't need to be paint, right? Pretty much. I simplify the problem. So we need to go sometimes through the hierarchy of items from the children to the parent and sometimes to the children, from the parent to the children and so on. So we need to go through the trees of parent and children. And you want to do it one time, right? And so if you call set flags with multiple flags, we update all of them one shot. But if you call set flag many times, then we go up and down in the tree sometimes for nothing. We could have done it one shot. So use it set flags with everything in one. If you have, like, on my demo, you remember I got this top-level parent that was doing nothing, right? It was a QGraphics widget with no content, no paint, nothing. I should have set the flag item has no content. I didn't do because I wanted to keep it for this slide. So what it means, if you set that flag item has no content, it means that in the painting code of graphics scene, we won't set up the painter and call paint on the item because we know it has no contents, it has nothing to draw. And setting the painter, with the opacity, with the transformation and stuff like that, take a bit of time. And calling a function also, even though it's not that slow, it's still stupid to call if you know that you won't do anything on your paint event. So if you just get a logical parent, set item has no content to true, it's a flag, and then the paint function won't be called. And then you save some painter initializations. Item change, so it's the notification thing I was explaining just before. Calling it is slow. Why? It's because, so you call item change with the changes that you have made on the item, and qvariant is a qvariant, and the qvariant is actually what you changed on the item. So, for instance, if you move the item, you will get a notification saying, "Oh, the position has changed, and here is the new position." And we use qvariant, so the API looks nice, right? You just have one function, but it gives a qvariant as parameter, so you can pass everything. It can be qpoints if the position has changed. It can be a real if it's the opacity that has changed, and stuff like that, right? It's a nice API. The problem is qvariant. Qvariant is not fast. And we tried everything. There is nothing we can do in Qt4 to make it faster. So if we want to make it faster, then we have to break the binary compatibility, at least. So try it. There's nothing I can change in Qt4 anyway, so avoid to call it too much. Try to avoid to call it. So that's why, for instance, set flags, I recommend set flags, because then you don't need to call it 2 times, right? You call it 1 time only. So be careful of, for instance, there are some flags in graphics item that send the geometry changes, the position changes and stuff like that. Really? Be careful when you set those flags, because it will be slower, really slow. So sometimes it's better than you actually do a kind of listener, you know, and you basically react to the, I don't know, let's say, call to set pose or whatever, and then by yourself actually listen to the changes that you want instead of calling item change. So add kind of action listener, or a bit like on Java, you know, you listen the item and then you actually trigger by yourself the changes instead of going through the item change. It's a bit unfortunate, but that's how it is, and there is nothing you can do for now. I think that's all for the tips and tricks and presentation of graphics view. So now the lessons learned, that what we learned when we actually did graphics view, because graphics view as a canvas like it is now, it's almost done. Like the canvas I'm talking about, right? Like the core feature of the graphics view is pretty much done, right? You get an item, you get a scene, a view, you can do transforms and so on. Features-wise, it's almost done. Perhaps we can use the subtree caching, but I don't think it's like a proper subtree caching, but I don't think it's worth the price to implement it actually. So it's a good framework. It can run fast on the devices, right? I mean, Migo Touch, Orbit, or the UI extension for Symbian 4, they are using it, right? And they will ship devices with it. So you can do really nice things with graphics view, but it's not perfect. What we notice is like what people do in the paint functions influence a lot the performance. What you do inside is like matters a lot. It's not very graphic card friendly, because most of the work that we do is software sides, clip path calculation, and like part of the transformation has to be done in CPU, but some of them could be done in the graphic cards. The effects, they works fine on some of them works fine on the device, some of them work fine on the desktop, but it's really fast, slow effects. We failed of delivering fast graphics effects. Making Q widgets works in the canvas. It helped many people, but it opened a Pandora box, and with a lot of bug reports and people trying to embed dock widgets inside the graphics view and expect it to work perfectly. Well, in theory you could, but the way the two frameworks works is too hard to make them communicate properly. Also, what we learn is like the expensive calculations, you know, for instance, on the paint, when you get the paint function called, then you can actually ask the expose rect of the item, you know, like the dirty areas pretty much, right? So that was a bad idea to actually always trying to compute this expose rect, because in many cases what you see in users code, they don't use it. Some of them do. Only sometimes some items in the scene actually use this expose rect, for instance, but all the others don't. And what we learn actually is like always calculating those things, for instance, always, even though people don't use it, is stupid. We should make the expensive calculations, like for instance the expose rate, on demand. So if you really need it, then we'll calculate it. It's slow, but you ask for slowness, kind of, right? So we change the behavior when we could. It's a bit bad, but that sometimes you have to do compromise. But it's one of the examples, and I can say more, but yeah, expensive calculation only on demand. Graphics item, it's a pure virtual class, right? You need to implement at least bonding rect and paint. I think that was a bad idea to put it pure virtual. We got a lot of problems that, I mean, it's mostly because of C++, right? Like when we actually catch the deletion of an item, it's when it actually enters in the graphics item destructor, right? because if let's say you have a subclass of graphics item, it's your destructor that will be called, but the framework don't know yet that the item is about to die, right? At least when it's not a key object. And so when we know that the item is about to, like, it's being deleted, is when we enter in the graphics item destructor. But then it's too late to, for instance, get the bonding right. Because of C++, you can't call the virtual method, right? On the graphics item level. So stuff like that, we have to add workarounds in the, for instance, in the index and so on, because we don't know the geometry anymore and stuff like that. So I think at the end it should have been pure virtual, just normal geometry 0, 0, 0, like graphics widget, and a paint that does nothing. Also, multiple views. I've seen some people using it, but it makes the code really complex and optimization hard. But at the end, I think it's a nice feature. And so the way it's implemented now, I think it could have been better. Now it's like we can still improve it a bit, but not that much. I think we're pretty much done about optimization in graphic view. It's not the common use case, the multiple views. So now it's like how we could have made it easier to add another view on top of it, and support the default one view, and then it's like somehow allows people to have different views. I don't know, by letting access easily. I mean, perhaps to let people to access to the actual rendered content of the scene, so they can actually grab a part of the scene and see it. I don't know, like exposing the surface of the scene, or I don't know, something like that. I don't know, but to improve the way it's implemented today. Now, how we can make a better usage of the graphic card? Well, I won't answer to that because Gunnar will do it. I think it's tomorrow. You better want to attend. It's basically how you can write efficient paint method. Could we improve graphics view without breaking the API? I don't think we can. At least in the binary and source compatibility way, nah. It has to be like that for now. Could we have a high performance canvas in Qt 4? I think we can. And I think the answer were given in the scene graph that was before this afternoon, but since for people that didn't go to that talk, you can still download the videos when they will be available. I would like to thank everyone for coming, and now you can throw questions to me, and I try to do my best to answer. Thank you. Any questions?
When you were explaining about the cache modes, and especially about the trick you did to simulate the sub-tree cache, how do you define when the sub-tree will be repainted or not? Is this something that is inside the plumbing of the effect thing?
Yeah, it's like the invalidating the big subtree pix map that you get from using the caching effect trick. You don't need to care about invalidating it. Graphics View does it for you.
Okay, so neither can you, for instance, move it to device coordinated cache or something similar to that?
Yeah, I mean, it's like...
It's a trick, right?
Yeah, it's a trick. I actually would be nice to have a support for a third cache. Now, is it worth to spend the price to actually develop it and make it works really nice? I don't know. That's something we need to figure out. I don't think it's worth the price. Okay. I think the cache, the trick will help some people. It's not perfect, but it will help many people. Like in my case, for instance, on Plasma.
Nice trick.
Yeah, I've seen some people in CADAB using as well this trick. So. Any other questions? Wow, come on, you have questions? I had I thought I would have a lot of questions. So
Hi, I was wondering, I may not have understood this properly, but when you draw the canvas, the graphics view, and there's a lot of children items, there's a first research of all the subgraphs or the subtrees.
Yeah, top levels.
Okay, the top levels. So what if you have a view in which you have, for example, one top level opacity for everything that's under it? Does this mean that everything will always be redrawn, or is?
Like you mean, like let's say you have a top level parent that has an opacity,
exactly.
The 0.
Any number, but
no. It's like no, because like we discard like on the subtree if we don't need to redo. Because let's say for instance you get a parent and then clips the children and then there is a children far away, right? It's possible in graphics view. This one will never paint it. We'll never paint it, right? It will be discarded. So what we get from the index is only a list of top level, not the complete subtree, right? It's then after that we recursively go to that subtree, and then we discard the one that we don't need.
Thank you.
And also opacity, for instance, if you have an opacity 0, whoop, we discard the guy, right? Don't need to paint it.
Hi. With the QGraphics effect classes, for example, I've noticed the drop shadow effect is sometimes slow if you apply a drop shadow to a complete hierarchy of items. Is it possible to get the source image only for the top level item, which may, for example, bound all of the entire subtree? Or does it always get the source?
No, you get always you always get the subtrees, complete subtree. Okay, there's no way you can ask no, there is no way you can actually ask for just the pix map of the top level.
That might be a nice optimization to have an extra boolean in there.
Yeah, that's actually a good idea. And yeah, I've already done actually. Yeah, I've already done.
Could you please remind where we can find the copy of this presentation?
The what?
Copy of this presentation.
I think the marketing people will send the presentation as well as the demos and everything. I can't answer, to be honest. You can ask one of them when you see them. I don't know.
Yes, you will.
They will be available. You will get them. So.
Hi, we've heard a lot of tips for animated scenes. In our projects, we mostly have static scenes, but there's a lot of activity in the views, like zooming, moving around. Do you have any tips for that?
Actually, zooming is the worst case of graphics views. As soon as you scale, is not very friendly, to be honest. It's one of the weak points of graphics view. Actually, when you actually scale the view, I don't see really good trick like this, except I don't know, rendering into a pix map the scene and then scale it by yourself. But then you will get bad quality. Otherwise, I will recommend to you the cache mode. But that's one of the flaws we have. Like the transformations is not fast. The transformations are not fast. But yeah, perhaps like if we sit down together, we can probably try to find something.
Yeah, hi. I'm really looking for a comparison with just using QWidget as a framework and QGraphics View. I mean, you spoke about using QWidget within Graphics View, but is there some kind of comparison like you use QWidgets lonely? Does it perform worse or better with the same use case?
It depends, actually. Graphics View has its own use cases, right? I mean, if you throw like 1,000 widgets into an UI, it will be slow. Graphics View will work a bit better. So stuff like that. And I mean, Graphics View, you have to see it as a canvas. As a canvas, right? QWidgets is mostly like, UI, right? UI bits like buttons and so on. So I would say Graphics View will perform sometimes better than widgets, but I've been shown that sometimes it's not true. Actually, yesterday, someone actually showed me an app on the mobile phone, and they told me that QWidget was faster than Graphics View for their use cases. So really it depends. But I agree that it's not easy to, when you have to design a new app, you have to choose, right? You cannot afford to develop both versions, right? So, me, to be honest, I would go always for graphics view, but that's my own advice. But, I mean, I develop mobile apps on my spare time, and I do it on graphics view. And if it's slow, I fix graphics view because I can do it. So, or I do my best to fix it actually, because, well, I mean, hacking Plasma helped a lot graphics view framework actually. When I was doing that, I fixed a lot of bugs and a lot of performance issues, but graphics view is not perfect. I think we can come up with something better. No one?
Yeah, I was at the scene graph presentation earlier, and that was quite interesting. But I'm wondering in the future, say you have an app that's based on graphics view, and you want to have the optimizations from scene graph. How can you migrate that to scene graph without? I mean, will you have to write the whole app again in QML?
For now, I don't have an answer, but I agree with you. That's a migration path that we need to solve. That's something that we should provide a proper migration path and the less painful with less pain as possible, right? So either by providing some kind of, I don't want to say it, but like a kind of proxy widget, but for the scene graph, right? But yeah, something. We need to find a migration path. For now, I don't have the answer, but I agree with you that it will be a problem. And this is using my KDE hat and say, well, we have a lot of code as well on top of graphics view, and we need to find a solution for that. So yes, I'll fight for a migration path. That's it. Thanks, everyone.
One more question.
I have a question about the maximum number of items in a graphics scene.
I can't answer. Actually, I've like ship demos as 1,000 items, and it works fine. I can't give a number. It depends what you do in the items, depends the complexity of the items, depends many parameters. In theory, it should be unlimited, right? But we know that it's not. But I don't know. It's like it depends really what you do in the scene. If you animate the scene, if it's a static scene, if the items are complex to draw, or if it's just rectangles that you move around. If it's just drawing pixmap, you can do a lot of them. But if it's like drawing text, then it will be slower, right? So it really depends the content. It's a generalist framework. We don't say, oh, it can handle like 2 million items and it will be fine. No, we can't. It's too complex. And actually, none of the canvas out there can actually say a number of items they can handle. It depends what you do in the items. Yep. Here we go.
All right. I hope everybody enjoyed the